Okay, so this is perhaps the last thing we need to say about Newton's second law. If you remember, we said that the resultant force is directly proportional to acceleration. So that means if you multiply the resultant force by 2, the acceleration is going to double as well, provided that the mass is constant. Okay, so for a constant mass, the resultant force is directly proportional to acceleration. And you can see on this graph here that for a resultant force of 0.2 newtons, the acceleration is 0.25 meters per second squared. If we double that to 0.4 newtons, you can see that the acceleration doubles to 0.5 meters per second squared, and so on. So we know that acceleration and force, so this is force, resultant force, and this is acceleration A. We know that when the resultant force doubles, the acceleration doubles, so resultant force is directly proportional to acceleration, and you also know that because this graph is a straight line through the origin. Whenever you have a graph that is a straight line through the origin, it tells you that the two different variables on the x and y axis are directly proportional. Remember, we also said that acceleration is inversely proportional to mass, okay, and this is for a constant resultant force. Okay, provided the resultant force remains the same, acceleration is inversely proportional to mass. So what that means is, if you look here, for a mass of 0.2 kilograms, you have an acceleration of 10. Okay, you can see that on the graph. For a mass of 0.4 kilograms, you have an acceleration of 5 meters per second squared. So when you double the mass, okay, the acceleration will half. All right, that tells you that these two things are inversely proportional. The mass and acceleration are inversely proportional. And you can see that from this graph. Now, just because the graph is curved like this doesn't mean it's inversely proportional. You have to double check it, like I just showed you, by checking that when you double one thing, the other thing halves. All right.